Okay, so welcome back to part two of this video. In part one, we left off at this point. We calculated the weight of just one washer, but we're not quite done yet, as I said before. What we're essentially looking for, we want to know, so how many washers can total a weight of essentially 16.824 newtons if one washer weighs 0.196 newtons. So I'm asking this question because it's going to help us solve for the final answer. And so in case you've forgotten, where am I getting 16.824 newtons? Well, I'm getting it from here. So the bucket had a weight of 18 newtons if you we already calculated that. Sorry, not 18 newtons. The bucket had a weight, I'm sorry, of 1.176 newtons, so that's that. And the maximum force of static friction we calculated was 18 newtons. So, like I said before, we can add 18 newtons onto the bucket before the box starts moving. So the bucket itself has a weight of 1.176 newtons, so we kind of take that away from the 18 newtons, and we're left with 16.824 newtons. And this kind of gap or difference will be compensated for by adding in washers. Each washer has a weight of 0.196 newtons. So how many washers can total a weight of 16.824 if one just weighs 0.196? This is a really easy like ratio problem. So if so how many washers are there in 16.824 newtons? And I also know that one washer has a weight of 0.196 newtons. Now the unit for this is not just newtons, it's newtons per washer, right? Because one washer, that's the weight of one washer. So I need 16.824 newtons, and one washer has a mass of 0.196 newtons per washer. So that's how I like writing down units, because now look what I can do. I can cancel out newtons, and I now get a number. I get 85.8. So 85.8 washers, if you want to write it down. I wouldn't write this as my final answer, obviously, because your teacher's going to be like, okay, 85.8 washers, you know where you're going to get like 0.8 of a washer from. You're not going to get 0.8 of a washer, so what you're going to do is you're going to be smart, and you're not going to let your teacher say that to you. You're just going to be like, well, this is approximately 86 washers. Right? So this is your final answer. There are 86 washers or approximately 86 washers in 16.824 newtons. And this is how many washers you can add, or it's the maximum amount. Let me write that down so I don't confuse anyone. So 86 washers is the maximum amount, or max number of washers we can add to if I can spell, to the bucket without moving the block. Because remember, we don't want to move the block. That is what the original question was asking us. You know, how many washers can we add to the bucket without moving the block? So that's what we have to keep in mind. And since the block only won't move until it has a maximum of 18 newtons of force exerted on it. So this is and there's already a bucket hanging on it, and now what we do is we just add washers onto it. So this is how I would go through this problem. Start off by reading the question, kind of like underlining the main values. There's a lot of extra words in there which you don't really need to pay attention to. That's what these kind of questions do to you. They're wordy, they're really wordy, and they try to get you kind of distracted from like the main point, you know. They're kind of like trying to weed you out, you know, like, let's see who actually, you know, study their stuff, who doesn't get distracted. This is all what exams and tests are about, right? So don't get distracted by all these words. You know, hang on to the important values, you know, and also the units of the values. Okay, yeah, you know, it's 4.4, 120, but don't forget to like look at the units. This is 120 grams and 20 grams. This could make the world of the difference if you actually ended up writing this as 20 grams or this as 4.4 grams. I mean, you're gonna get the entire question wrong. And then, you know, you went through the right process, you have your right equations, your methodology was right, but if you have the wrong units, you're just gonna get the wrong answer, and it's just gonna be like, it's gonna be a total bummer. So please make sure you read the right units. What else do I want to say? This part is totally optional if you don't want to just sketch out a quick little diagram. If you're running out of time, you don't have to do this. You know, I don't think it's part of any question unless your teachers are actually asking for this on a test. This is just something I like to do, so, you know, I kind of like, I'm not really a visual person, but in cases like this, it's good to know, like, you know, if it's an apparatus, like, okay, how is it actually set up? Like, where's the box and where's the bucket and what does this thing look like? So it's just a quick little sketch. Free body diagram, you need that. Without this, you know, it's kind of expected in any dynamics problem when you're dealing with Newton's laws and forces. You're going to have to draw a free body diagram. It's kind of expected in every question. I mean, sure, you know, you could. This one was easy. It only had like a normal force and you know, force of gravity, but then there you have like your way more complicated questions where you get, you know, like a bunch of forces acting on an object, and then it's kind of like you're going to get confused when you do it all in your head. So make sure you draw a free body diagram, or I just like to call it an FBD in short, and you know, analyze your forces according to that. Your negative signs, again, your negatives are basically for your direction. If you forget about your negative signs, again, go like, you know, choose a corner of your page and define your upward y direction as positive, and so let's just say this is positive y, and so, you know, if you're going down, it's obviously a negative y. Since these are all in the y direction, these are all y component forces, obviously, you know, up and down. So it's clear from this, you know, this is a negative y force. So make sure you have the correct negative signs, or you're just going to get like, you know, a negative in front of this number, which then would make the entire thing incorrect. So that's that for that part. Part B might be a little bit confusing for people. It's because it's not a straight up kind of calculation question. You kind of have to go through a bunch of little steps. So start off with whatever information you know for sure you know. So we obviously knew, like, you know, there was the mass of the bucket was given. So, you know, if you have a mass of an object, you know, obviously we know what the force of gravity is. It's all not the force of gravity. We always know the gravitational acceleration. It's 9.8 meters per second squared. We always know that, and so we can immediately find a weight, or, you know, FG, whatever you want to call it. So you find that, and then you move along. You know, you kind of like try to make sense like of the question. So what is the question asking me? You know, so just work through the question. If you want to write things like this out in your test, or, you know, in your assignment or whatever, like actually writing out these quick little sentences helps me make sense of my process more. But if you can straight up see what the question's asking for, you don't even need to write this. You can just, you know, go up and calculate it. But this is just the way I like to do it. And yeah, so just work through it logically, and this is one of the more simpler problems. Obviously, you know, I'm pretty sure you've been through complicated ones in class, and I'll probably make a video on one of those too. But this is one of the really simple dynamics and equilibrium and Newton's laws and those kind of problems. So you know, at the end of the day, we shouldn't really have any problems doing these kind of questions. But other than that, that's it for this video, and hope you guys had fun, and I'll see you guys next time.